Hey Algebra 1, here we are in Chapter 6, and we're looking at Section 6.3. We're still working with the idea of inequalities, but now we're going to be solving multi-step inequalities, which is going to look a lot like what we've been working on before. So here we have some information. So the boiling point of a substance is the temperature at which the elements change from liquid to gas. The boiling point of chlorine is negative 31 degrees Fahrenheit. That means that chlorine will be a gas for all temperatures greater than negative 31 degrees Fahrenheit. If Fahrenheit represents the temperature in degrees Fahrenheit, the inequality F is greater than a negative 31 represents the temperature for which chlorine is a gas. If C represents degrees Celsius, then here's the way we would actually change from from Celsius to Fahrenheit. You can solve 9/5 C plus 32 being greater than negative 31 to find the temperature at which the degrees Celsius for which chlorine is a gas. I know that was a whole lot of mumbo jumbo, but the bottom line is you can translate, since you know that chlorine is going to be a gas at any temperature greater than negative 31 degrees Fahrenheit, you can use this formula to figure out what that temperature would be in terms of Celsius. And so you see them doing that here by saying that since Fahrenheit is equal to this in terms of Celsius, you can set this greater than negative 31 by substituting. Okay, so now we're going to get into our problem. Solve multi-step inequalities. So the inequality here involves more than one operation. It can be solved by undoing the operations in the same way you would solve an equation with more than one operation. So find the temperature in degrees Celsius for which chlorine is a gas. So just like with any equation, I like to draw a line here just to think about the different sides, but I'm going to remember this is not an equation, it is an inequality. But what I do to one side, I can certainly do to the other. So I'm going to add a negative 32 to both sides, and what I'm trying to do is isolate C. I want to find that temperature. So, or at least the range for that temperature, right? So I'm going to subtract 32 on both sides, and then I'm left with 9/5 C is greater than, I almost wrote equal to, but it's greater than negative 63, right? I'm adding two negatives and it's still negative, and I just add. Now, what I'm going to do is undo what's happening to C. C is being multiplied by a fraction. To undo that, I'm going to multiply by the fraction's reciprocal, 5/9. But what I do to one side, I do to the other. The question I would ask myself now is, hey, do I have to switch signs? I'm multiplying both sides by a fraction. And the answer is no. The only time I flip signs with an inequality, this is from the last lesson, is when I'm multiplying or dividing both sides of the inequality by a negative number. And since I'm not multiplying both sides by a negative number, no sign will be switched here. All right. Now things cancel out. C is greater than, now what's this value here? Well, negative 63, let me do a little bit of cool math. Negative 63 times 5/9, what I can do is, instead of multiplying 63 times 5 then dividing by 9, which is totally legit, which is how we handle fractions, I'm going to divide 9 into 63 because I see that can reduce my value to make my multiplication easier. Think about what I'm doing. Instead of multiplying then dividing, I'm going to divide then multiply. Some teachers will call this cross canceling because I'm canceling across the multiplication, which is totally legit. I get a negative 7 and I get a 1 because 9 goes into negative 63 negative 7 times, and then I end up with negative 35. So Celsius temperature when the Celsius temperature of chlorine is greater than negative 35 degrees Celsius, we will have a gas. Here in example 2, we're going to use inequalities involving negative coefficients. So here we go, multi-step. We're going to solve, and then they ask us to check our solution. We'll do that. We need to isolate B, so we're going to add a negative 19 to both sides. When I do that, I'm left with negative 7b is less than, the sum of these guys together becomes negative, I think 25? No, 35. Yeah, 35. negative 35. The next step is to isolate b by division, but what I realize is I'm dividing both sides of an inequality by a negative, which tells me I need to be alarmed and flip the sign. Remember, when we divide or multiply both sides of an inequality by a negative, the sign flips, it changes. So now that I've got that, I have b is greater than a positive 5, because negative 35 divided by negative 7 is positive 5. So now we check. So I go back to the original equation. What I should have said is we're going back to the original inequality. And what I'm going to do to check is to put an answer in that satisfies this inequality. I almost put 5 here, but that's what we do when it's equal to. Here it says b has to be greater than 5. So I'm going to put a number in that's greater than 5 and see if it's true. So if I do negative 7, a number greater than 5 is 6. I could use 10 or 15 or 1,000 if I wanted to, but 6 is decent enough for me. So I'm going to put a positive 6 in there because that's greater than 5, and I'm going to see if it satisfies the original inequality. Negative 7 times 6 is negative 42 plus 19, and I'm hoping that the sum of these two numbers is less than 16. So let's check it out. When I add these guys together, I get a negative 23, which is indeed less than negative 16. So I feel satisfied that this solution is correct. Here in example 3, we're going to write and solve an inequality. Write an inequality for the sentence below, then solve the inequality. 3 times a number minus 18 is at least 5 times the number plus 21. So the number, let's say n is the number, all right? And it's going to be the number. And let's go ahead. So 3 times a number, so that would be 3n minus 18. I'm subtracting 18 is, so this is where we get the comparison, is at least. Now this is always tricky for me, so I have to think about it. If somebody is at least 100 pounds, could they be more than 100 pounds? Could they be less than 100 pounds? When I hear somebody is at least, let's say, 100 pounds, that means that they're 100 pounds or greater. So when I think about that logically, when I read this thing, 3n minus 18, is at least, meaning it's equal to or greater than the thing I'm about to talk about. It's at least. The smallest that it could be is this or more. It's at least 5 times the number, that's 5n, 5 times the number plus 21. Plus 21. All right, so this is going to be an interesting situation. I think I'd like to read it over again just to make sure. 3 times a number minus 18 is, I'm comparing it, at least, it is at least, the smallest it could be is 5 times that same number plus 21. I feel confident that I've done right, and so now I'm going to solve it. And it's multi-step, but I can handle that. On one side of the inequality, I want to have my n terms, so I'm going to just choose my n terms over here, and I'm going to put my constants over here. If my n terms are going to be on my right side, I'm going to get rid of this 3n by subtracting on both sides. I'm left with negative 18. And I have 2n plus 21. The next thing I'm going to do is get rid of my constant term over here, which is 2. That's gone. I have a negative 20 is greater than or equal to 2n. Now what should I do? Well, I'm going to divide both sides by 2. Will my sign flip since I'm dividing by a negative number? I'm going to divide a negative number here. Anybody? Hopefully you realize that the sign does not flip because 2's not negative. Remember, the rule is if I multiply or divide both sides of an inequality by a negative number, that's when the sign flips. Just because 20 happens to be negative, or this is negative 20, that doesn't change anything. It's the fact that I'm not dividing by a negative number. All right, let's bring it home. N has to be less than or equal to negative 10. Did they ask us to check it? We could. If we were to check it, we would choose a number that is equal to or less than negative 10, plug it into this equation, and I would see that, plug it into both sides of the inequality, and I would see that it satisfies the inequality as it stands there. All right, ooh, look at this one. This one looks good. So there's a whole lot going on. I actually do, you think I'm being facetious. I really do mean it. This looks really kind of fun. So, like, I like to look at it and kind of figure out, okay, what should I do first? So we remember the order of operations. We know we need to do what's in parentheses first. Since I can't actually do anything in the parentheses, multiplication is going to supersede subtraction and all of that stuff. So I'm going to multiply. I'm going to distribute this -2. So on the left side here, I have 3D minus -2 times 8 is going to be a -16D. -2 times a -9 is going to be a positive 18. Make sure that makes sense. On this side of the inequality, 3 is going to stand. I'm actually going to do something that's a little slick here. I'm going to distribute a -1. When I distribute -1, I get -1 times 2 is a -2D. -1 times 7 is a -7. And so now I've got everything out of the parentheses and I'm going to join like terms together. These two guys are going to come together to give me a -13D plus 18. And these guys over here, this 3 and this -7, will come together to give me a -4. So now that I've simplified either side of the inequality as much as possible, it's now time for me to choose a side where I want my D terms and choose a side where I want my constant terms and go about my business. I like my D terms to be on the side where there's most D's. Now this is a lot of negative D's and this is fewer negative D's, so more D's are over here, if that makes sense. I don't know if that makes sense, but you'll see it in a minute. When I add the 13D to both sides, I end up with a positive number, which kind of makes me feel kind of nice. So over here, I end up with a positive 11D minus 4. The next thing I'm going to do is add 4 to both sides, right? Because I didn't put it here, but I want my constants on this side of my inequality, and I'm left with 11D is less than 18 plus 4 is 22. And this is pretty awesome because 11 goes in very nicely, and D is less than 2. So that is my answer. And I'm feeling good about myself because it was a lot of work, but it was kind of fun at the same time. So here we have another problem that looks nice and involved and beautiful, but it's called the empty set. So we're going to figure out what that means. So we're going to go about our business and solve as we usually would. Little distributive property, we get 8t plus 16, little 8 hanging out here. I'm going to distribute the -3 through here. So I have -3 times t is -3t, and a negative times a negative is a positive 12. That's less than, distribute the 5t. 5 times that gives me a -35 plus 8. The next step is always to join like terms as best as possible. 8t minus 3t is 5t, so I'm simplifying each side of my inequality. 16 plus 12 is going to give me 28. There we go. Now I'm going to join some like terms over here, and I get 5t, -35, and a positive 8. I don't know why I'm having trouble doing this in my head. What is that? It is a negative 27. There we go. Took me a little while. Sorry about that, guys. And now, what? Something's looking crazy. Let's see what happens. So I'm going to, let's say, add 27 to both sides, maybe, to get rid of that. When I do that, I have that 5t plus this thing here, which is going to be 55, is less than 5t. Already something's flaky's going on. 5t plus some other number that's huge is going to be less than 5t itself. And right now you're thinking, well, maybe t is negative. But still, how can you add something to one thing and then it be less than that same thing without the addition? Let's keep going. Let's see what happens. If I subtract 5t from both sides, right, I'm going to end up with 55 is less than 0, which is bonkers. It's bonkers. It is what I would call a lie. It's impossible. And when you have a situation that's impossible like this in mathematics, there's no t value that's going to make this true. The answer is the empty set, or sometimes we might write no reals. And so you see why that happened. So, what I want you to do is make sure you recognize when you are solving a problem when something like this occurs so you don't feel like, what is going on? Well, look, guys, that's it for me. I hope that everything makes sense. I'll talk to you soon. Take care.